before what I was talking about with statistics. It's collecting, organizing, and interpreting data. So when I told you guys, oh, here's how you are in relation to how second academic is, I collected information, collected your all's test scores, and made a comparison, interpreted where were your weaknesses, where are their weaknesses, who's got a stronger score, proficiency, and distinguished than the other. So that's all it is. Statistics is just collecting information, organizing it, and then giving its interpretation of, or its meaning. When you collect data, you collect it through a survey method. So how many of you have ever gone to like the mall and somebody comes up and goes, hey, can I have 5 minutes of your time? You just answer a couple quick questions. And yes. Yeah, those are people who are collecting information that might be something about maybe a new store that they want to present, or maybe it might be about life insurance policy. So maybe they might be gearing more towards older people. It's different things that they're just trying to collect information about. That's a survey method. Put off. Okay. A population versus a sample. So when we talk about a population, we're talking about the large group of people. So like when we're talking about national elections, a population is the entire United States. That's the population. The sample, that would be the people who actually are voting, because not every single person votes. Even though everybody has the right to vote, not every single person chooses that right to do it. Okay, so that would be your sample. So right next to population, I want you to go ahead and write that this is the big picture. And right next to sample, I want you to write that this is the small picture. So the sample is the group that is actually being surveyed. So not every single person is going to be surveyed. Just like I said, not every single person is going to vote. So the people who actually vote, that's the sample size. Now, what's really important, and sometimes it doesn't always happen when people are presenting this information, your sample has to represent your population. It must represent the population. I don't have any. You want a sample that's going to represent your population. So for example, if I'm wanting to talk to you or figure out, you know, whether we've assigned too much homework or not in the school, do you think I'm just going to ask teachers? No, because are the teachers going to be a fair representation of everybody in the school? No. We're a part of the school, so yeah, you probably should still ask some teachers, but you also want to ask a mixture of 6th grade students, 7th grade students, 8th grade students. I want to make sure I ask students that are in standard classes. I want to make sure I ask students that are in gifted classes. Okay, I want to get a very good range or variety of different kinds of people in that population. I'm not going to ask everybody in the school, but I ask little portions here and there. Okay, so what we're going to do here is just real quickly identifying which group is our population, which group is going to be our sample. So we're talking about a topic on dress code. We've got students in the middle school and 7th graders in the middle school. Which group is considered to be the population, the big picture? Mia? Students in the middle school, right? That encompasses everybody. The 7th graders in the middle school, that's your sample. That's just a portion of the people in the school. Flavors of ice cream. We've got customers at the ice cream shop in town and residents of the town. Which one's my population, Sirius? Residents of the town, right? That's the big picture. Everybody that lives in that town versus the people who are actually in the ice cream shop, which is your sample. So you need to be able to distinguish between your population size and your sample size. And again, your sample needs to be a good representation of your population. If it doesn't represent, it's not a fair survey, which we'll talk about biased and unbiased tomorrow or Thursday for you guys. All right, let's go down to the bottom. Now, I told you guys before when we were doing our proportions unit that you would be using proportions for the majority of this semester. Here it is again. We're using a proportion to be able to identify or predict how much can be represented within a certain total. So here we've got students that have brought in pictures of where they went over summer vacation. So we have 6 students that went to the beach, 4 to camping, 7 that just stayed home, and 11 that went to a theme park. First thing I want to do is I want to identify the probability that somebody went to the theme park. So how many people went to the theme park? 11, right? And then what goes on the bottom? It's out of what? The total, that's right. So we know 11 people went to that theme park. How many total people were surveyed? 28, right? If we add all these together, 6, 4, 7, and 11, we're going to get 28. So the total is out of 28. So there's our probability. I can't simplify it. I'm just good. 11 over 28. Now I want to use that probability to make a prediction. So you're going to take the probability that you have, which is that 11 out of 28, and you're going to set it equal to another ratio that will help you to make a prediction. So I want to know how many students out of 560. So where's that 560 going to go? Top or bottom? Bottom, right? Because that's a total, right? Out of 560 total students, how many would I expect to have the theme park? So that would be X on the top. So once you've got this set up, then we just do our cross product. What two values do we multiply together? Good, 11 times 560. And then what do we divide by? 28. Divide it by 28. Good, so 11 times 560, divide it by 28. And we're going to get that we should expect about 220 students that went to the theme park. Now remember, it's a prediction. Is this exactly how many? No, it's approximate. Okay, so about 220 students is what we would expect. Try example 3 on your own on the back. What is the probability for A? Problem A. Sorry, oops, I'm up at the top. What is it? 3 over 5. Very good. So we're talking about how many students have a blog, which happens to be 6 students, out of your total, which is the 10 students, but we can actually simplify this. 6 over 10 can be simplified to 3 over 5. So the probability is 3 over 5. Now, using that probability, let's make a prediction about how many students out of 250, Julian? Oh, you're trying to ask a question? What's up? Even if you didn't simplify it and you use this value down here to find, it would still give you the same answer. However, if the question was only asking you for the probability, you'd need to simplify it to get the correct answer. Okay? Did you want to try B? You didn't do it? You did? What did you get? You got it right. That's correct. So you take the probability being 3 over 5 or 6 over 10 if you didn't use the simplified version, and you set it equal to a prediction, X over 250, and then you just do your cross product. You're going to multiply 3 times 250, then divide it by 5. So 3 times 250 gives you that 750, divide it by 5, and you're going to get X is equal to 150. Okay? Now, problems 4 and 5. Problems 4 and 5, these are percentages, so they're not really giving you a probability, but if it's a percent, it's out of what? 100. So you can set up the percentage over 100 and then use that to find your prediction. So let's do problem 4 together. We have a survey that 85% of people use basically emojis in their texting. If there's 2,450 students, how many would you expect to use emojis? Sorry, it's my... So we know that we've got 85 out of 100, right? 85% out of 100%. We want to know how many out of 2,450, how many people. So that's just the basic setup. We're going to do our cross product of 85 times 2,450, and then we'll divide it by that 100. Now, when we do that, we're going to get a decimal answer. However, can I have a decimal answer if I'm talking about people? No. Can't have a decimal answer if you're talking about people. So you need to make sure when you're reading the problem, sometimes you can keep it as a decimal, sometimes you need to round it. So this would approximately be 2,800 or 2,083. You want to round it correctly. 2,083. Go ahead and try example 5 on your own. All right, Harmon, what'd you get? Not quite. Serious? No. First of all, what's the percentage that they're talking about? If they're saying not having a television, what percent is not a television? What percentage is that? 54%. It's 54% in here. So I know it's hard to see it up here, but on your paper, you should easily be able to see that's 54 versus 46. So it should be 54% out of 100. You want to know how much out of 1,725. So serious, what would that be? 932. Very good. So when we do our cross product, we multiply 54 and 1,725, then divide it by that 100. Again, it's going to come out to a decimal, 931.5, but we're talking about people, so you got to round it, 932. Make sure you know when to round versus not rounding. Okay, again, you guys are going to have an assignment in which you can do extra credit on the very second page. You have to do the first page no matter what, but the second page is going to be extra credit.